Here we are going to find the general solution to the differential equation x times y plus y prime equals 100x. One thing you might want to do to start with, since we are talking separable differential equations, is perhaps rewrite y prime, which we know to be the derivative, as dy dx. Next, let's subtract xy from both sides of the equation, and then factor out an x so that we can actually separate the x's from the y's. If we now multiply both sides by dx, you'll see that our next step needs to be to divide by the quantity 100 minus y so that we can get the y's on the left and the x's on the right. We then take the antiderivative of both sides of the equation and find our antiderivatives as we typically would. On the left side of the equation, we have 1 over 100 minus y, and this is something we would have to do by using u substitution. If we allowed u to equal 100 minus y, du then would be a negative 1 dy. So as we do our antiderivative, we know it's going to be natural log of absolute value of u, but we also need to include a factor of negative 1 in there. Therefore, our antiderivative on the left side ends up being negative 1 natural log of the absolute value of 100 minus y. On the right side, antiderivative of x is easy. It's simply 1/2 x squared plus c. That is the end of the calculus that's involved in this problem. Here on out, we need to employ some algebra, some laws about exponents and natural logs in order to get this finally in some kind of equation in terms of y. The first thing we'll want to do is divide both sides by a negative 1. As I divide my plus c by a negative 1, I simply could leave it as plus c, except now it's a negative, because remember c is just representative of a constant. We now need to use our definition of a natural logarithm in order to rewrite this natural log equation in terms of an exponential equation. That would give us the fact that e raised to everything here on the right side of the equal sign would equal 100 minus y. We can eliminate the absolute value bars because notice how this e quantity is always going to be positive, so we can eliminate our absolute value bars because of that. Now on the left side of the equal sign, we're going to employ some laws of exponents, but going backwards, as you typically would use them. Because in the exponent we have a sum, we can separate out the e term as e raised to the negative 1/2 x squared times e to the c. Remember, according to the laws of exponents, because these bases are equal, the exponents would have been added. So you're literally going backwards from how you typically would use them. E to the c, however, simply is another constant. You can use any letter to represent that. I often use k, but some people use capital N. Some even use still c, because it just represents a new and improved c. You can really use anything you'd like. If we therefore rewrite what we have, substituting k in place of e to the c, we now have k times e raised to the negative 1/2 x squared equals 100 minus y. It's now easy to rearrange this equation so as to get y by itself, and in the end, for the general equation, we have y equals 100 minus k raised to the e to the negative 1/2 x squared.